With these, we're asked to condense all three of these into one single natural logarithm. Now this is going to follow the same rules as other logarithms. This one is just a natural logarithm, but it works the same if it's a base 10 or a base 4 or base anything for that matter. Okay, so the first thing we need to identify is there anything that we can condense down and move to an exponent. And we look at this, I've got a 5, 7, and a 3 here that I can. So we're going to look at the rules for our exponents, our laws of exponents, and here we go. And what this basically means is if there's something out in front here, whatever this quantity is, we can move it and that can become the exponent here. And let's kind of look at an example. If I have a 2 natural log of a, that 2 can be moved around so that it is the exponent of a. This is considered in its condensed form here. This is the expanded version, but if we're condensing, here's what it would look like. Now let's look over here. I have a 5 here. That 5 will move around and become the exponent on my x. That'll be x to the 5th. This 7 will come around and be the exponent on my y. And this 3 will move around to be the exponent on my z. So let's do that now. And again, this 5 here became x to the 5th. It just moved around. We followed the same rule like we did over here. The 7 moved around to be y to the 7th. And then the 3 moved over to be the exponent of my z. Okay, well now I've got these all have the same base and it's subtraction here. So let's look at the rules here. If it's subtraction, assuming they all have the same base, and they do, the base on these is e, the number e. So I've got it's subtraction, same base. Now what I'm going to do is divide here. This is x divided by y. And let's look at one that's somewhat similar. So if I've got a natural log of w minus natural log of x, because they have the same base and this is subtraction, I'm going to divide these. This would be w divided by x. So you'll see that here. Okay, well, looking over here, I've got an x to the 5th. We know that's going to be on top, using the same, similar to the example here. The difference here is that I've got two subtractions, if you will. And what that basically means is that both of these two are going to go on the denominator. Okay, so when we do that, x to the 5th will be on top, y to the 7th, and z to the 3rd will both be on the denominator. So here's what it reduces down to. This is our one condensed logarithm. X to the 5th on top, y to the 7th, and z to the 3rd. That's because we have this subtraction sign here.